So, again, continuing on with our one-link planar robot. This time we're on part D, and in part D we're wanting to find values of L and theta corresponding to the coordinate pairs, all dimensions measured in centimeters. So we've got a list of x, y coordinates. There's about 5 of them, and they want us to find what L and theta are. And so, again, we're talking about our one-link planar robot. So let's zoom out so we can see everything. We've got, so for each one, we've got what this xy coordinate is. We're being given that ordered pair. And what we found out in part C was that we can determine L by using the Pythagorean theorem, that since it's the hypotenuse, it's the square root of x squared plus y squared. And we can determine theta by using the tan inverse of y over x. Of course, there was a caveat to that if we're in quadrants 2 or 3, we have to add 180 degrees in order for that to work out. Or if we're working in radians, we would need to add pi to that, which is the same as 180 degrees. Okay, so our list of examples here, we got our table set up. We know that these are x values, these are our y values that correspond to those. L is going to be found using that equation. Tangent theta, tan inverse is going to get us theta. And I didn't include it on there, but we may need to add in the 180 to get things right. So let's go ahead and just do our first one. We know L is going to equal the square root of 1.3 squared plus 2.1 squared. And that's certainly something we want a calculator to do. 1.3 squared plus 2.1 squared. And if you don't remember how to square something, remember the caret gives you the power. Yeah, and so that one's straightforward enough. We get that it's 2.4. I'm going to go ahead and round these to 3 spots, even though these are only to 2. Just because I want a little bit more accuracy, a few more significant figures in there. So that I get it's 2.47, what must be the length of our robot arm in this case, and that theta is equal to tan inverse of y, which is 2.1 divided by x, which is 1.3. Again, calculator is very handy for that. Notice I'm doing these in degrees. You could do them in radians. But if you want to check your answers against me, I suggest doing them in degrees. In this case, again, a lot of times in terms of if we're just talking about an angle, we think better in degrees, at least here in the US. So I get 58.2 degrees. It's in the first quadrant, which is good because x and y positive, I'm in the first quadrant, so that one's okay. Alright, so the second one, L is going to be the square root of 3.4 squared plus 0.8 squared. And one thing I'm going to have to be careful about is where I put my parentheses in this one. So let's go ahead and write it in here. 3.4 squared plus, and if I just put negative 0.8 squared in there, and I've intentionally kind of done it wrong on purpose, because see what's done here is, if you can see the way it rewrote it, is it's going to do the 0.8 squared and then make it negative, so it's actually subtracting that out. I don't want that to happen. To be the right terms, I need the negative to get squared and go away. So I want to make sure to put that part in parentheses. So I put parentheses around the negative and then hit enter and get the correct number. So this time I get that it's equal to 3.49. So if you got 3.30 or 3.31, you probably messed up your negative sign when you're punching it in your calculator. Alright, theta is going to be tan inverse of the y is negative 0.8 and the x is positive 3.4. So tan inverse of negative 0.8 divided by 3.4. I did tangent and not inverse tangent, that's why I got a strange number. That's why calculators are great, but you've got to be, they're only really as smart as you are. Alright, so if I put in the correct function, tan inverse of negative 0.8 over 3.4, I get that this is equal to negative 13.2 degrees. Negative 13.2 degrees would be down here in the fourth quadrant, which is good because I've got negative y, positive x, so that's correct. If it tells me it only wants positive answers, I could add 360 to that. And get that it's 346.8. If it wanted that one, that might be. Again, you'll see some questions where it asks you for just the numbers between 0 and 360. So if it's that, obviously a negative number is not right. Make sure you've got an angle that corresponds, but it's the same angle. All right, third one. Starting to get the hang of this. Negative 4.1 squared plus 6.7 squared. Again, I want to be careful about putting the negative 4.1 in parentheses so that it gets squared with that negative and the negative part will go away. I suppose when you put it in your calculator for doing the square root, you could just ignore the negatives since it'll come out the same numerically. But it's usually smarter to write down everything. That way you don't confuse it with thinking it was positive to start with. So 7.85 for the length of that robot arm. And theta is going to be tan inverse of 6.7 divided by negative 4.1. Again, if you had a long list of these, it might make more sense to do all of these and do all the lengths at one time and then all the thetas at one time, but that leads to bigger problems in trying to keep track of where things are. Because if I were just going down the list, I got negative 58.5, I wouldn't worry about that at all. But I know that since this is actually negative x and positive y, that's actually in quadrant 2. So I need to add 180 to that, so I'm just going to take my answer and add 180. And so I get that it's actually 121.5 degrees. So again, be careful. If you get negative 58.5 and write that in there, it looks right in your calculator, but it's going to be wrong for an answer, whether that's in the computer or I'm grading it. It's not the right place. All right, keep going. Number 4. This time they're both negative, so that's quadrant 3. So if I already know that up front, I know I'm going to have to add the 180 over there. So 1.5 squared. So for this one, square root of negative 1.5 squared plus negative 3.3.1 squared. I get 3.44. So that one's 3.44 centimeters long. And that theta is going to be tan inverse of negative 3.1 divided by negative 1.5. And I know I'm going to have to add 180 in there to get the right number. So I'm just going to go ahead and set that up to start with since I know it's quadrant 3. So tan inverse negative 3.1 divided by 1.5 plus 180 on the outside of the parentheses. It looks right on the screen. Oops, except that, nope, I missed the negative on the 1.5. So I'll bring that one back up real quick. I'll put a negative sign in there. Now it looks right. Tangent inverse of negative 3.1 over 1.5 plus 180. I get 244 degrees. Which is out here in the third quadrant like we would like. So that's good there. Alright, so the last one tells me that x is negative 4 and y is 0. Well, that one's pretty easy to figure out. If I'm just looking at the graph, I know that L has to be 4. I don't need to square it and take the square root of it. It's 4. And theta, did I do that backwards? No, that's right. X is. So if it's negative 4, we're over here. So I know that theta must be 180 degrees. And again, I could try to do tan inverse. I imagine, well, that one would be okay. Because if I do tan inverse of 0 divided by 4, I get 0. Then I have to know I'm over here, so I have to add 180 degrees. And that's it. So there's our 5 answers. We'll want to keep up with those because they're going to be useful for another part. But that ends part D.